Okay. In the past two lectures, we learned about mesh and nodal analysis, which are the two systematic way of analyzing circuits. We learned about combining resistors. We learned about combining sources, and now we're going to talk more about sources. The circles with the positive and negative terminal that we've been calling voltage source are actually called ideal voltage sources. And I'm going to discuss why they are called ideal. Now, can you tell me what is the current in the first circuit? 2 amps. And what is the current in the right circuit? 1 amp. Okay, this is my question. What is the job of a voltage source? For example, this one, the 10 volts. What does it do? Okay, provides a potential difference between its positive and negative terminals, equal to exactly the value that is written beside it. Now, this is my question. Does it matter how much current is being drawn from it? Does it?
For the voltage?
Yeah, the voltage 10 volt that is dropped between the positive and negative terminal. Does it depend on the amount of current that is being drawn from it? No, because as you can see, the 2 amps and 1 amps are different currents, obviously, but the voltage between the positive and negative terminal is still 10 volts. That is the definition of ideal voltage source. Terminal voltage is independent of the current that is passing through its terminals. Anything wrong so far? Now, can you name an example or an equipment that has this behavior? Car battery. Do you agree with him? Why not?
A battery. There's a positive and a negative.
What kind of battery you mean?
Double A wire.
Double A's?
Double A wire.
So no matter how much current you draw from it, the voltage is always 1.5 volts? No. So again, I'm going to repeat my question. Can you name an example of an ideal voltage source? That's not a DC. That's AC. No, we don't have that. I mean, the name is ideal. Do you have anything ideal? No. Okay, so this is a mathematical concept. We don't have anything that resembles this. Like someone mentioned car battery. Have you ever tried starting the engine while the lights are on? What happens? They dim, right? They get dimmed. Why? Because the current that's feeding the lights, the voltage that is feeding the lights is going to be decreased because of a huge amount of current that you're drawing from the battery, okay? Or, let's do this. Let's find a car battery. How much is the voltage of a car battery? 12 volts. Connect the multimeter across the terminals of the car battery when the car is off. You measure 12 volts. Now, at the same time that the multimeter is connected to the terminals, crank it. Start the engine. It will go down probably to around 11 volts. So the voltage of the battery across the terminal of the battery that you're measuring is changing. It's not ideal. We're going to understand why this happens, and then that's fundamental to our next discussion. Okay, so let me ask you this. So we know that car battery cannot be modeled by that circle with the positive and negative terminal, because that circle provides a constant voltage across the terminals no matter how much current you're drawing, and car battery is not the case. So how should I model a car battery or any practical voltage source? Not ideal, practical. How can I model them? So as he mentioned, if the voltage across the terminals of that creature changes, it means that inside that creature there is something that responds to change in current, and hence the voltage across it will change. What kind of element has this behavior? Resistor. A resistor, depending on how much current passes through it, will change its voltage, right? So a practical voltage source is an ideal voltage source which is in series with some resistor. And that resistor is usually called the internal resistance or resistor of the device. Where does that come from? For example, the voltage source that you have on those workstations, this is a practical voltage source. Why do we need to consider some internal resistance for it? Because inside that box, there are a lot of parts and wires and everything, and they all have resistances, right? So it's not zero. Ideally, it would be zero, but it's not. That's why we have this case. So, in reality, battery has some finite internal resistance which receives a voltage drop depending on the current drawn from it, and changing the terminal voltage of the battery. Okay? Before I forget, this is the last lecture that is going to be on exam 1. Okay? So the lecture on Wednesday is the first lecture of exam 2. It's not on exam 1. And just a reminder, exam 1 is on next Wednesday, 6 p.m. Not the coming one, next Wednesday. After the, what is that holiday? Easter holiday. Now, okay, so I want you to, first of all, what is Vs? It's an ideal voltage source, right? How do we model a practical voltage source? Look at the dashed red line. Whatever is inside that, it's called a practical voltage source, which is an ideal voltage source in series with a resistor. Everything making sense so far? Okay? Very good. Remember, you don't have access to what's inside the red box. You only get the voltage from across the terminals, which is called V battery, right? Does that make sense? So imagine that inside the red box is just completely opaque. You don't see what's inside, and you only have access to the terminals. And you connect it to some sort of load. If you don't know what load is, anything that receives power from a source can be called a load. A resistor, a capacitor, a refrigerator, a starter of the car, anything, it's called load, okay? Now, that current that is drawn from the source is labeled, and this is my question. Now, is V battery equal to Vs? The only way that V battery is equal to Vs is when? I mean, yeah, but Rs cannot be zero. What can be zero? The current, right? If you don't draw any current from the source, then V battery, exactly the same as the car that is not running or is off. If you connect a multimeter, there is no current being drawn from the source, and so the V battery is equal to Vs. Now, I'm going to write an equation here. I'm going to write a KVL here. V V battery is equal to Vs minus Rs I drawn. So you see that the more current you draw from, you pull from the source, your V battery is going to decrease. One very important question for exam, for homework, for your experience in handling circuits. Is there anything wrong with my KVL? Did I choose a valid loop to write KVL around? Or there's something wrong with it? Sorry? Which one is in series? What's wrong with? It's not connected. Do you see that part? When I jumped from the positive terminal of the battery to the negative terminal, the circuit is not even connected. Nothing is there. So does that make my KVL invalid? Keyword, me and Braylon. Do you remember the example I gave you previous week? I can write a KVL between our heads in this room. Are we connected? I guess not. So for KVL, do you need some physical elements or wires or whatever? No. You can go from any point to any point and write a KVL, as long as it's a closed loop. It doesn't even have to be a mesh. It can be a big loop. You still are allowed to write a KVL, as long as you return to the original point. So when jumping from top to bottom, I have written the voltage as V battery, which is perfectly valid and correct. I'm entering from the positive terminal, so I write it as positive V battery. Okay? So remember that. I want you to remember it. In order to write KVL, you don't need a circuit to actually exist there. Okay? Have you had Physics 202? Okay, is it about magnetism? Are you familiar with Faraday's law? Or in high school or somewhere? If you change the magnetic flux passing through a loop, it will create some electromotive force, right? And that loop doesn't have to be closed. You still create that electromotive force. What happens if the loop is closed? Then you will have current, okay? So current needs a loop to be closed, but voltage, no. Okay, so this is the definition of practical voltage source. That literally was one of the questions on the exam. You know that you have, if you have looked at the previous exams that are provided to you on Canvas, I published it, right? Yeah. Okay, good. This was one of the questions. What is the definition of a voltage, practical voltage source? Not a current source, so any choices that has a current source in it is not the answer. And the resistance should be in series with the voltage source, okay? That is the definition. Okay, for the car battery shown below, if V battery is 11 volt, find Rs. So what should I do? Sorry? KVL, yeah. Negative 12 volts plus RSI plus V battery is equal to 0. See, I'm writing V battery with a positive sign. Why? Because with the direction that I'm using, I enter from the positive terminal and exit from the negative terminal. So I write it in positive. So from here, substitute every value that you have, and this is the value of Rs that you get. I don't know what's that. I think it's very small, yeah. It's 10 milliohms. It's a small, right? Why can't I just neglect it?
A large current, which makes
Yeah, a large current is being drawn from the circuit. That makes the voltage drop across that 1 volt. 1 volt is not negligible, okay? So yeah, depending on the current, you might be able to neglect it as you did it for the power supply that you used in your mini labs, right? But here, no, because the current is just too big. Any questions so far? Okay. Now, we all learned right now that a practical voltage source is an ideal voltage source in series with a resistor. Now let's make 2 measurements. Let's do 2 tests. The first one, I keep the terminals of my practical voltage source open, and I connect a multimeter across the terminals. What's the voltage that I measured? Before you answer that, I'm calling this voltage VOC. Why? Open circuit, okay, VOC. So can you tell me what is the value of VOC? Again, please. So VOC is the voltage drop across RS? What is the voltage drop across RS? Let me ask you a simpler question. What is the current being drawn in this circuit? Because it's open, right? The name is saying it, open circuit. So the current is 0. Okay? So, again, what is VOC? Do you all agree with that? What's the role that the resistor plays if there isn't any current passing through it? Nothing. It's like a piece of wire. So your terminals of VOC are connected to the terminals of VS, so they are exactly equal. Did that make sense? Because it's open. I'm gonna just write it backward because I'm gonna need it later. To the right-hand side, I connect the terminals together and I measure the current. What is the current? A simple Ohm's law, right? Vs over Rs. Do you agree that I can write VOC over Rs? If it's the what? There is no if. Why do you need to?
I was going to say if it's the same, points you're measuring.
Oh yeah, this is a. This is the same circuit, if that is what you're concerned about. Yeah, this is the same circuit. These are not 2 different circuits. CVS and RS are exactly the same. I'm just doing 2 measurements on the same circuit. The left one open circuit, the right one short circuit. So instead of writing VS, I can write VOC because I just proved they are equal. Anything wrong with that?
Yes, that one doesn't have a current. So the resistor is straightforward. Let's do a KVL. Let's do a KVL on the circuit.
To the right-hand side?
Wouldn't it be the VS equals VOC minus?
There is no VOC here. VOC is for that circuit, okay? And we just proved that it's equal to VS. Am I not right?
There's a different scenario.
Yes, different scenario. But do you agree that Vs is constant?
Yes.
It's fixed. So, and if you measure across the terminal, that will give you the value of Vs, right? If it is open. So instead of writing Vs here, I can just write VOC. No?
No, because it's a current. Do we determine that's the difference is one is a current? Because if you expanded this one, that would be Vs minus Rs times I, but I is 0. So we just get rid of that.
Okay, now I get what you mean. So what you're saying is that Vs minus Rsi is the voltage across the terminals, right? The thing is, if I is 0, I would call that VOC. Otherwise, I wouldn't call it VOC. I would just call it V terminal.
Yes.
Yeah?
Yes.
So, if I is 0, the voltage across the terminals of the battery is exactly equal to Vs. Now here, do you agree that ISC is Vs over Rs? The first one, this part. You agree with that, right? You agree with that. Now, do you agree that Vs is the open circuit voltage measured across the terminal?
Say it again?
Do you agree that Vs in here is exactly the open circuit voltage measured across the terminals? Open circuit voltage, not the general voltage. Open circuit voltage.
No, it's the independent source. Right?
Are we talking about open or short circuit? I don't know what you want to talk about.
So the Vs is from the negative terminal of before Vs to the positive. That's what Vs is.
Yes,
Not on the right side can change. Right?
but I don't care about the right side. Am I saying
yes, you
anything?
added a wire. Are we doing the short circuit?
Does that change the value of Vs?
No.
Okay, let's do this.
But you're
Let's do this. Let's get to the bottom of this.
But VOC
Okay,
is not Vs
let's resolve that issue.
with the current, right?
Okay, I have a black box.
Yeah.
I don't have access to the inside except the fact that I know there's a practical voltage source inside. Meaning there's a voltage source and some resistor, okay? Inside the box. I don't have access to it, I cannot see inside. There is some voltage source, ideal, the circle, and some resistor. Now, I connect the terminal of that thing to a multimeter, and I measure the voltage.
Okay.
And it's open, because multimeter is open. It should only measure the voltage. The reading of the multimeter tells you 10 volts.
Okay.
What is that 10?
That 10 is the Vs. Right?
Perfect.
Okay.
So the open circuit voltage that you read is exactly the value of Vs.
Okay.
Let's remove the multimeter, now put it in series and read the current. Okay? The current that you read, of course, is going to be equal to Vs over Rs. Do you agree with that so far? That's just basic Ohm's law. What is Vs? Do I already know it? I just measured it, and it's 10. So I can replace it with 10. 10 being the open circuit voltage.
Okay.
Did that make sense? We can discuss it after I'm done, okay? If you're still not satisfied with it. Okay, so instead of Vs, I wrote VOC over Rs. Now, I'm going to rearrange this and write it like that. Anything wrong with it? Let's just rearrange the equation. What are these two equations telling you? These two red ones. Recalling the example that I gave you with the black box. A black box is given to you. You only know that there's a practical voltage source inside. By doing two measurements, I can determine the value of the ideal voltage source and the resistor in series with it. You only need to do two measurements. One open circuit, one short circuit. The open circuit voltage will give you the ideal voltage source. The short circuit current, the open circuit voltage divided by the short circuit current will give you the value of the internal resistance. Okay, this is how we can measure or how we can model a practical voltage source. So the quantities VOC and ISC completely define the practical source. So if this is your practical source, what is the value of the voltage source? The ideal voltage source is V open circuit. What is the value of the resistor? VOC over ISC. Did that make sense to everyone? Except you two? Okay. Practical current sources. Same story, or I just said it like the dual of what we talked about in practical voltage sources. So current sources ideally will give all IS to the load. But in practice, you have some resistors in parallel. Remember, in parallel with the current source. Now, in order to understand this, I'm going to ask you this. If RS is open, let's open RS. How much current will pass through the load? Yeah, IL is the label. Give me an expression for IL. Sorry? Yeah. No, RS is open, not RL. RS is open. IS, right? All the current will pass through the load. Nothing goes through RS, right? RS is open. Okay. What if RS is not open? Then what? Some of it will go through RS, some of it through RL. How do you find IL? Current division. So you see that the idea of a practical current source is that not all the currents will be provided to the load. Some of it will go through the internal resistance. Okay? Now, let me ask you one question before moving forward. So this is the ideal this is the practical voltage source. What should be the value of RS for the whole thing to become ideal? No. If RS value is 0, then it won't depend on current anymore, right? So how to build or how to fabricate a very, very close to ideal voltage source with a very, very small internal resistance. Okay? Now, how do you make a very close to ideal current source?
Very high resistance.
A very, very high internal resistance, RS. Why? Because
they don't want to, because it proportionally goes to
exactly. You don't want RS to draw any current. And RS won't draw any current if it is too high. Or you can think of this way. You want to make it open. In the limit, what does open mean? Infinite resistance. So you want to make it infinity. I know that you love mathematics and limits and everything. So can someone tell me what's the limit of the right-hand side expression if RS approaches infinity? 1. 1 times IS, so they become equal. Okay? So mathematically, physically, and everything, we just we should understand what the ideal current source is. Very similar to the case that 98% of you accepted. We're going to talk about two measurements on a black box that is a current source, a practical current source. So again, if I measure across the terminals, it's going to be called open circuit voltage. Now, based on the left-hand circuit, do we agree with the equation that is written at the bottom? Anything wrong with it? Ohm's law. The open circuit voltage should be the current that's passing completely inside the source through the RS. Nothing comes out. Is that obvious why? The name of the voltage, the subscript, is screaming. Open circuit. It means that it's not connected to anywhere. So all the current will pass through the internal resistor and it will be RSIS. Okay, let's move to the second circuit here. Now, if I short circuit it and I measure the current, short circuit current, how much is ISC? IS, can someone justify it? Why?
There's no resistance.
What happens to the internal resistance? It gets bypassed. So all the current will pass to the output. So I have two valid equations, right? Based on this, I can say that if I want to model a black box based on practical current source, the ideal current source is equal to the short circuit current, and the resistor is equal to VOC over ISC. One question. Just focus on the top circuit and this one at the bottom right. Okay? The top one is the model of a practical voltage source. This is a model for a practical current source. Again, a black box is given to you and they ask you to do two measurements. You measure open circuit voltage and short circuit currents. And they ask you to provide a circuit model for that equipment. Which one do you suggest as the model? Let me ask you another way. Can you certainly say what's inside that black box? If it is a voltage source, practical voltage source, or a practical current source? There's no way you can answer that question because they are completely equivalent. So you can either come up with that circuit model or this one, depending on which one you prefer for your circuit analysis. Both of them are completely equivalent. Okay? Now we're going to actually talk a little bit about this. So look at the two green boxes instead of black boxes. Okay? Now they are transparent, so you can see the inside, so you can know that the left one is a voltage source, the right one is a current source. But we are going to connect them to the same load, and we are going to have the same voltage across the load. Or let me put it this way. We want to have the same voltage across the loads. So in other words, we want to see under what conditions these two green boxes are completely equivalent. Remember that the two RS are exactly the same, RLs are the same. We want to see under what conditions VL is equal to the VL left is equal to the VL right. Okay? So let's write equation for or just to let me just call it VL1 IL1 and this one IL2 VL2. I think it makes more sense. I want to find a relationship to make VL1 and VL2 exactly equal. Let's write VL1 to the left side. What is VL1? How do you calculate it? The fastest possible way. Sorry? Okay, that's correct, except that I want you, in these two circuits, which quantities I know? I know Vs, I know Rs, and I know RL, but I don't know VL and IL. So writing VL in terms of IL is not actually ideal. So I want to write it in terms of the known quantities, which are the two resistors and the voltage source. So what do you suggest? Can you bypass that?
Do we know VS, RS, RL?
Yeah.
So can we not?
You can find IL. That's perfectly fine. I'm just practicing with you to find the best way to handle these circuits. Is there any way that we don't have to find IL and then find VL?
Resistance, like a ratio.
Voltage division, right? You don't have to find current. So do you agree that VL1 is Vs times RL divided by RS plus RL? Do you agree with that? Okay, so that is VL1. Let's find VL2 to the right-hand side. How can I find VL2? The fastest way possible.
RS or RS plus RL times IS.
That's a current.
Oh, times RL.
For those of you who didn't follow what he said, what's inside the parentheses? Based on what concept it is? Current division. So it will give you the current that passes through RL. But I'm interested in VL2. So what should I multiply that with? RL. Do you agree with that? Okay. So current division and RL. Or an alternative way is that, do you agree that VL2 is across RL and RS in parallel? So calculate the combination of them in parallel and multiply it by IS. That will give you the voltage. Okay? Both the same. I'm going to rewrite this like that. VL1 and VL2. What's the condition that VL1 is equal to VL2? When VS is equal to RS IS. I can write it here. VL1 is equal to VL2 if VS is equal to RS IS. So what is so fundamental about this? It means that if you have a voltage source, ideal voltage source, in series with a resistor, you can remove it and replace it with a current source in parallel with the same resistor. See, RS. Now, in the new circuit, in the transformed version, what is the value of the current source? It's Vs divided by Rs. That is called source transformation. You can replace a voltage source which is in series with a resistor. We can transform a voltage source which is in series with a resistor, into a current source in parallel with the same resistor, and vice versa. And remember that the voltage source is Vs, the resistor is Rs, the current source is Vs divided by Rs. Okay? And resistor is again Rs. Let's do an example and see how that works. So the power absorbed by 5.8 kilo ohm resistor. Okay. Let's see if we can transform anything in this circuit. Can I do any transformation on the 3 volt voltage source? Yes or no?
Can you turn it to a current source in parallel with the 10 kilo ohm?
Could you please read the important result again for me, Ethan?
Oh, right.
What's the problem?
Yeah, it's in parallel.
It's not in series with a resistor, so you cannot transform it. See? We can transform a voltage source which is in series with a resistor. Very, very important. The voltage source that you have here, it's not in series with anything. How about, do we have any current source that is in parallel with a resistor? So we can go for that one. What should I put instead of that? First, find the terminals, and instead of drawing something in parallel with these terminals using the current source, use a voltage source and a resistor in series. What's the value of the resistor? Sorry? 10 kilo ohm, the same resistor. What's the value of the voltage source? 4 milliamps multiplied by 10 kilo ohms, which is 40 volts. Is there anything else you can change here? We better not do that. For what reason?
Oh, yeah.
Yeah, we are looking for the power absorbed by that. If you combine it, then you don't know what's what, right? But to the left, we can combine 10 and 9.7. Can I do any more? Yes?
Shouldn't the positive be on the bottom?
Do you agree with him? Yes, thank you. I got it wrong. Why? Yeah, compare these two. This is the basic, this is the fundamental note that we had on source transformation. The positive sign is connected to the terminal or is associated with the terminal where that, what do you call that? The arrow head is pointing, right? So can I do any more transformation or no? Sorry? Can I? No, they are not in series, so you cannot combine them. I don't think I can do anything. The only thing I can do is change it back to current source, which just shows that I'm stupid. So I'm not going to do that, right? So that is it. Let's solve the circuit. Yes?
Would it hurt your equation when you all split 10 ohms and series behind it as a part of it? So,
No, you can move the 10 kilo ohm before the 5.8 or below the voltage source. It doesn't matter. As long as they are all series, it doesn't hurt anything. How do you suggest I solve this circuit? Mesh. It's super easy. So whatever you do, it's fine. Okay. Let me actually talk about some policies that you should follow when answering questions. This is a serious problem for some students. They overthink a problem, okay? And if you use the worst possible method of analyzing that specific circuit, it takes 5 minutes, and they spend 6 minutes deciding whether to use nodal or mesh. Okay, this is a serious problem with the students. So if it is obvious, go for it. If it is not, whatever comes naturally comes first, go for it. Don't doubt yourself, just focus on it and solve it. Okay, it's not worth overthinking which method to choose. That is the first one. The second one is, I'm now simplifying the circuit using source transformation just to practice it with you, okay? Otherwise, I wouldn't do anything to that original circuit. I would just directly go for it and solve it without any simplification. Because that source transformation might take, I don't know, 30 seconds, 1 minute, and then the overall time that I spent on analyzing the original circuit would be probably less. So simplifying the circuit is good whenever you see it very obviously and you can do it very fast. For example, in the first circuit, I would definitely combine the 9.7 and 10 because this is so obvious. But I would probably won't go for source transformation. Sometimes you have to. You will see toward the end of this lecture that sometimes you have to do source transformation. But I'm just suggesting that you have to be very wise about what to do and what not to do, especially on exam. Okay, so current nodal analysis is fine for this, but I'm going, mesh analysis is fine for this, but I'm going to do nodal. I wouldn't even call it nodal. I'm just going to write one equation and that's it. So can you tell me what's the red voltage? Sorry? 3 volts. And what is the purple voltage? Negative 40 volts. Now, because it's a resistor, the 5.8 kilo ohm, do I need both voltage and current to calculate power, or one of them is enough? One of them is enough. If you remember the equation, V squared over R or Ri squared. So I'm going for current. Let's call it I. Can someone tell me what is I? The single most important thing in this course. Say it again.
It's the difference between those two voltages over the 5.8 kilometers.
Only 5.8? What is I? Now compare that with that piece of circuit. What is I? 3 minus negative 40 divided by 5.8k plus 10k. Do you agree with that? I is equal to 2.72 milliamps. So what is the power? The power absorbed by the 5.8 kilo ohm resistor is equal to 5.8 kilo ohm times I squared. And it's equal to 42.91 milliwatts. Any question, problem? Let's find Ix in this circuit. Okay, so again, I can just directly go and solve it, or I can do some simplification. Is there any source transformation that is obvious here? Left and right current sources can be changed, right? So let me remove them. Okay, to the right hand side, someone tell me what is, I removed the 9 ohm in parallel with the 1 amp current source. So what should I substitute it with? You have a resistor in series with a voltage source. What is the value of the voltage source? 9 volts. What is the value of the resistor? 9 ohms. To the left hand side, you will have a resistor, again, in series with a voltage source. What is the value of the resistor? 3 ohm. What is the value of the voltage source? 15 volts. Any problem? Anything else to combine? 3 and 4. And? And nothing. Just 3 and 4. So this will be 7. And can I combine 9 and 2? Yeah, I could do everything I want, but it doesn't make it better, right? What's the problem with that?
You're looking for Vx, and that's
I'm looking for Ix.
well, we need to find Vx probably.
Exactly, because you have a dependent source that depends on me. So better not touch that, okay? Is there anything else you see here that can be simplified?
This one.
Isn't that a current source in parallel with a resistor? Isn't it?
Yeah.
Okay. Because I know that you like it, so I'm going to do this. What is the value of the resistor? What is the value of the voltage source? 51 Vx. Where is the positive terminal? Right. Okay? Okay, let's get to the bottom of this, huh? Let's simplify it as much as we can until it cannot be simplified anymore, just as practice. I'm not saying it's a good idea to do that on exam, but let's do it as much as we can. Okay, so right now, what can I do to further simplify the circuit?
17 and 9.
17 and 9 combine. So instead of 9, I will write 26, right? What else?
You change the 15 volt and 7 ohms to a natural current source.
The 15 and 7 to a current source. Are you getting somewhere with this?
You can then combine the
Yes.
parallel resistors.
So let me write this as 15 over 7 amps, and this is 7 ohms. Is there anything else I can combine in this circuit? Right now, this is just a line, right? Is there anything else I can combine?
7 and 7.
The 7 and 7, right? So I will write it as 3.5 ohms. There's one more thing that I need, just forget about resistors, something else can be combined. Why not? They are both voltage sources. I will do it next step, not to confuse. Plus or minus? Minus. Right? Again, the current source that is in parallel with the resistor, I'm going to change it back to voltage source. So I'm going to have a voltage source that is in series with a resistor. What is the value of the voltage source? 15 over 7 times 3.5, which is 7.5 volts, and this is 3.5 ohms. And finally, this is what I'm going to have. I have a resistor that is 2 ohms, and here is Vx, here is Ix. I have another resistor which is a combination of 26 ohm and 3.5, which is 29.5 ohms. And I have one voltage source, which is the combination of everything. And what is its value? 1.5 minus 51 Vx volt. Any problem? Can you tell me what is Ix? Use Ohm's law and tell me what Ix is.
4.5 times 54 is over 31.5.
Do you see where the negative sign comes from? Yeah. Because the current is entering from the negative terminal of the resistors. If you're not comfortable with that, write a KVL. If you don't see that, write a KVL. One equation, two unknowns, right? I need another one.
Vx is
2ix, and then you can solve it. Question, problem? No? Okay. I have a 10-meter long rope. Okay? And I want to just, I want to construct a rectangle with it. Just moving it around, maneuver it, and just fashion it in a way that it's a rectangle. Okay? And the length of the rope is 10 meters long, so you cannot cut anything of it. What rectangle gives me the highest area? You made square, you mean? Okay. Why? Why? Okay, do you remember that? Have you ever done that before? Do you remember what that kind of problem is called? Optimization, okay? You just find the area based on the sides of the rectangle, x and y, and then do some manipulation, and you will take the derivative and set it equal to 0, right? For the maximum. Now, very similar to this case. Now, look at the practical voltage source, Vs in series with Rs, and some load, Rl. Now, let's see. I don't need you to memorize or learn how to do this proof, but it's nice to know how it is done, okay? You don't have to recreate it, but let's go through it one time. So, do you agree with the first equation? The power absorbed by the resistor RL is just RL multiplied by the square root of IL, okay? We had this before. And do you agree with the second equation? Based on Ohm's law, the current through the circuit is equal to the voltage Vs divided by combination of resistors. Let's combine this together and you will get to this equation. Now this is my question. What should be the value of RL so that maximum power is transferred from the source to RL? So this is the equation or expression for load power. If I take its derivative and set it equal to 0, I will find at which point or which value RL will receive maximum power. So take the derivative based on whatever equation you remember, set it equal to 0, and this is the condition. Not shocking, right? RS should be equal to RL. It means that if you want your load to receive the maximum power from a practical voltage source, your load should be equal to the internal resistance of that source. Under that condition, it receives maximum power. Okay? Now, I don't need to say, but instead of the green box, if it was a current source in parallel with RS, the same scenario. Again, RL should be equal to RS. I mean, it doesn't change anything. What is important here is that the questions that you get from these concepts are usually two parts. The first part asks you, what is the value of RL so it receives maximum power? Memorize this. I mean, it's obvious, RS is equal to RL. So the maximum value of RL that the value of RL that receives maximum power is equal to RS. That's the first part of the problem. The second part of the question, usually they ask you to calculate the maximum power. How much maximum power is, okay? And in order to calculate it, what should I do? Do you agree that I can just plug RL equal to RS in that equation? Okay? Just plug RS instead of RL and simplify it, and you will get this. Let me write it as PL maximum. I want you to memorize this. What's inside this? The voltage squared over 4 times RS is the amount of power that is received by the load. Let's do an example and see how usually these problems are given to you. Okay. What value of RL will cause the remainder of the circuit, very important, remainder of the circuit to deliver maximum power to RL? What is the maximum power absorbed by RL? Very easy question. I can just answer it in one line. So RL should be 3 ohms in order to receive the maximum power, and the maximum power received by that is going to be 12 squared over 4 times 3, right? Based on the 2 equations that we did. See, RS should be RL and VS squared over 4RS. So I can just say RL should be 3 ohms, and the maximum power delivered to it is 12 squared over 4 times 3. And I just didn't care that there's a 6 ohm and 7 ohms in the middle. This has happened before, many times, by more than 50% of you. When I ask, find the maximum power or find the condition for maximum power transfer, 51% of you usually say RL should be 3 ohms. What's wrong with that picture? Based on what?
This is different.
See here? This is called a theorem. I know you're engineers, you hate theorems, okay? But we prove this case, okay? So if you want to use it, make your example look like this. How? How can I get rid of 7, 6, 6, 7, and
We have to find
3 ohms?
equivalent resistance.
How?
So RL equals RL plus 7 first, and then do all the adding up.
So I would,
Let me first understand what he said. What do you do?
I would set RL equal to the combination of like RL 7, 6, and 3.
But there's a voltage source there. How can you combine them?
I don't know, those two, RL and 7 are in series, and that's a parallel of 6, and then that's in series with 3. Did you do that or not?
Oh.
so I would kind of,
Oh yeah, I got it. I got what you mean. That's nice because I've never done that before.
That's on your homework.
Huh?
That's on a couple of the
So you
homework.
get 7.2
Probably do
something.
that.
No, because there's an easier way of doing it. But that was nice. Sometimes I prefer the harder way. Yeah, but let's see. Is there any way that I can change what's inside the red dashed box to a voltage source which is only in series with one resistor? And if yes, what do you use to do that? Yeah.
Should you change it to a current source and then make the 3 and 6 ohms parallel, combine them, and turn it back into a voltage source?
Exactly. So you use source combination and source transformation, sorry. You use source transformation to manipulate what's inside the red dashed box and change it to something that looks like this. And then you can use the theorem. So what's the value of the current source? 4 amps. What's the value of the resistor in parallel with it? 3 ohms. Then change it back to voltage source, right? Or first you can first combine these two. What is 3 in parallel with 6? 2. Write it, I'm going to write it step by step so you won't get confused. What's the next step? Change it back to voltage. So this is 2 ohm plus 7 ohm, which is 9 ohm, and this is 8. So maximum power transfer. What should be the value of RL? 9 ohm. And what is the maximum power? 8 volt squared divided by 4 times 9 ohms, right? Based on the formula. The value is 1.778. Watts. Any problem? You can start your in-class assignment.